Part 2 of Lesson 11.2 involves finding the limit as h goes to 0 of the difference quotient, f of x plus h minus f of x all over h. Well, what is f of x? Each question that typically changes, that is a function that's given to us. And so what we need to do is we're going to plug in x plus h for each x in the function. In this case, there's only one, it's x squared. So f of x plus h would equal x plus h instead of x, quantity squared plus 3. Well, what's that? As a reminder, x plus h squared is x plus h times x plus h, which when you FOIL it, we get x times x squared, x times h, 1xh, h times x, another, right? hx and xh are the same, so two of them, plus outer and last h squared. So that is x plus h quantity squared. And so that got plugged in right where the x plus h squared was, plus 3. Okay. It is possible for x to appear more than once, so make sure if it does, if this was plus 3x, we would plug in x plus h and for that x as well. And I split this back when we learned this process, just this part, into 3 steps. The first step was calculate f of x plus h. Sometimes that is a long process if we have a cube or something complex. Then we're going to subtract the original, right? So subtracting f of x means minus x squared plus 3, right? And so distributing the negative, I get minus x squared minus 3, and so I rewrote them under the pieces that are going to disappear. And then we have 2xh plus h squared left over. And now I bring back the divide by h, right? Once we have it all simplified so that the only pieces left must have an h in them, we get 2xh plus h squared divided by h. Canceling one h from each piece, I get 2x plus 1h, right? And now, then we're plugging in h goes to 0. So again, I brought limit of h goes to 0 back once we canceled things out. And now the limit as h goes to 0 of 2x plus h gives us 2x plus 0. And therefore, our limit is 2x. Now, I would highly recommend looking at the function and the answer. There's usually a quick pattern you may be able to see for some of these simpler problems of these. That also applies to others. In general, in pre-calculus here, honors pre-calc, we will stick with some of the more basic parts. They will expand on this in calculus, guaranteed. Next, 12. F of x equals 2x squared plus 2x plus 1. So again, just a heads up, symbol-wise, sometimes they call this f prime of x for like derivative. We'll get into that term in a little bit though. So again, we need f of x plus h minus f of x all over h, and then take the limit as h goes to 0. And basically that means we're plugging in h as 0. Well, why can't we do it right away? Well, we get 0. And again, as a reminder, this is basically we're doing slope at the point, so to find the rate of change of something. Okay, so that's what the difference quotient is. Plugging x plus h in, notice we have 2x squared plus 2x. There's 2 spots for x plus h to be plugged into. So we have 2x plus h squared plus 2 times quantity x plus h plus 1. Well, I need to do x plus h squared first. And again, just like the last slide, that's something you may want to have written down somewhere. You will see this a lot. X plus h times x plus h is always x squared plus 2xh plus h squared. So 2 times that quantity plus 2 times x plus 2 times h, right? 2 distributes to both pieces plus 1. Again, this is also a common area for mistakes. People focus on the highest degree and forget to plug x plus h in here. You need to plug it into both spots. Next, distributing the 2x squared plus 2 times 2, 4xh plus 2 times h squared, 2h squared, and then plus 2x plus 2h plus 1. And then that was just the f of x plus h part. Now we're subtracting the original, so minus 2x squared plus 2x plus 1. Notice these will always cancel out. So that's why you see these purple dotted lines. This minus 2x squared cancels with this plus 2x squared. This minus positive 2x cancels with the plus 2x. And this minus 1 cancel with the plus 1. And what's left? Whatever's left should only have h's. So I got 4xh, 2h squared, and another 2h. And now we bring back the limit as h goes to 0 of 4xh plus 2h squared plus 2h all over h, canceling 1h in each. H goes away. Now I have plus 2h plus 2. This doesn't just give you 0. When these cancel, we get plus 2. And now we're plugging in h is 0. So 4x plus 2 times 0 plus 2. Basically, that'll just go away, and we get 4x plus 2 is our limit. These problems do take quite a bit of time at first, but again, look and try to see a pattern between 2x squared plus 2x plus 1 and this 4x plus 2. How might we get 4x and plus 2 from mainly the first two pieces, but from all three pieces? Moving on to the next one. Now we're dealing with a fraction, 1 over x minus 5, which just for the shortcut reason can also be referred to as x minus 5 to the negative 1. And the formula is limit is f of x plus h minus f of x all over h as h goes to 0. And again, f of x plus h is what? 1 over x plus h minus 5. Pretty short and simple. And next we need to subtract the original. So minus 1 over x minus 5. And to do this, we need to multiply by the common denominator, which is 1 of each, x minus 5 times x plus h minus 5. And then when we do that, this piece, the x plus h minus 5 cancels, and we get x minus 5. For this piece, the x minus 5 cancels for this fraction, and the x plus h minus 5. And so what's left over is x minus 5 minus x plus h minus 5 all over. H is still in the denominator because we're divided by h, right? Times these other two pieces, x minus 5, x plus h minus 5, right? Because this h was in the denominator even though we had another one. And so just to combine the denominators, that's what happened here. Okay, sorry, I forgot about it. There's the h. And now we get what? What happened, right? So let's quick look at the numbers. We have x minus 5 minus x plus h minus 5. Distributing the negative, minus x, minus h, right here, minus a negative 5, so plus 5, and we got x minus x, they canceled out. Negative 5 plus 5 canceled out, so minus h was all that was left over. So right here, this is all that was left over. Okay, now looking at the rest of this here. Notice we have negative h over h, these cancel, so it's a little bit of a mess here. But we had minus h over h times the two parentheses. We can do that for now, right? And these cancel and gave us a minus 1 in the numerator and over the two parentheses. So that's what they're doing now, because once we cancel the h, we look to plug in h is 0. So negative 1 over x minus 5, x plus h minus 5, that's what I meant by the two parentheses. Plugging in 0 right here, this is going to become x minus 5 as well. X minus 5, and we get negative 1 over x minus 5 squared. We're not going to FOIL that out. This is the way that you can kind of see potentially where, you know, the pattern comes into play. From x minus 5 to the negative 1 form of that, right? Moving on, we've got one more example. Lastly, we've dealt with fractions. We've dealt with quite a few exponents. Now, another exponent would be the square root. X minus 7 to the half, or square root of x minus 7. So plugging it in, we have square root of x plus h minus 7 minus square root of x minus 7 all over h. Now, we can plug all these in because right away when you look at this, this looks like a rationalized numerator problem again, and that's what we're going to need to do. So to rationalize the numerator, we're going to multiply by the conjugate in both numerator and denominator. And then what are we going to get, right? When we multiply a squared minus b squared, if this is squared, square root goes away. This is squared, square root goes away, but the negative is going to distribute to both pieces. So that's what we have here. Minus quantity x minus 7 gives us a minus x, opposite of minus 7 plus 7, and then we look for what cancels. So in this case, let me see some x here. We got minus x, and the x cancels. Plus 7, minus 7 cancels, and we're left with h. So you rearrange those, but you can see where those are going to cancel and just get h in the numerator. And then the h will cancel in the denominator, giving us 1 over square root of x plus h minus 7 plus square root of x minus 7. So that means once the h cancels, we are plugging in 0 for the h we have left, which will give us 1 over square root of x minus 7 plus square root of x minus 7. We've got two of these though. 1, 2. So we'll write that as 1 over 2 square root of x minus 7. And now we can rationalize this, multiplying by square root of x minus 7 on both top and bottom. We get square root of x minus 7 over 2 times x minus 7, which is square root of x minus 7 over 2 times x minus 14. When I distribute it, you technically can leave it right here. This is fine. This is also the same as 1/2 x minus 7 to the negative half. Right? Again, just a little bit more for trying to see the pattern from here. Right? How do we go from here to here? Okay, so pretty interesting case. And that wraps up part 2 of 11.2.